Hey, Chris Park from Arking Games here, and I want to talk about Swizzle Lists. Lest somebody think that this is a weird mixed drink reference, which I was not aware of. It's actually related to computer graphics, which this is not exactly what I'm doing, but it's kind of inspired by this. Depending on when you're sending computer textures to the graphics card, depending on the graphics card, sometimes it has to quote unquote swizzle the bits, where it's moving what the RGB are around, and there's a variety of other cases in which swizzling happens. And so I thought, okay, I've got this weird new data structure that I'm quasi-inventing. I'm sure it's not a very original idea, but I wasn't basing it off of anything explicit. And so based on that, the closest thing I can think of is this reminds me of swizzling a little bit. So what is the deal with the Swizzle List? The As the comments in here say, it's all about the efficiency. It's supposed to be really good at doing a couple of things, mainly iterating and adding and deleting. And other than that, it is not supposed to be even able to do most other things. For instance, it doesn't delete references to anything. It doesn't per se. It doesn't, in a garbage collection sense, it doesn't delete references. So if we cared about garbage collection, this would break it. But we're using this with pooling in general. So I've got Photoshop here for some visual aids. So imagine that each column here is a Swizzle list. Now, or a Swizzle list usage scenario, let's put it this way. So when we first define a Swizzle list, we say, how big is it? And that is an underlying array, which it actually creates two of. And those are going to be empty, but they're fully defined, given that most arrays, unless it's a value type, which are structs, go on the stack. If it's assuming that it's a more complex type, a class that goes on the heap, it's basically, you can think of it like being pointers. So we've got a collection of pointers which it holds on to. Now, we've got these two lists which are of a certain, and I call them lists, but they're actually arrays. The reason I use the terminology list is that in C#, they have a built-in type called list, and that lets you go in and do a variety of different operations. You've got a list that you define, and it's supposedly empty, and then you add 3 entries, and now it's got 3 entries, but then you can delete them, and now they're gone. And you can add more, and it's actually, now a length of, 5, whatever. But what's really happening under the hood with the lists in C# is that it actually defines, I think that's probably close enough, it defines 16 and an actual array underneath there. And so then as soon as you start it, it's defined an array of 16. You add a few, and it's pretending like there's 3 in there, and you take them out later, and it pretends like it's empty, and so forth. When you add the 17th item, suddenly this thing doubles. I'm just going to guess that's about right. Suddenly it doubles underneath the hood and says, all right, now we've got 32 items in there. And so as you keep on adding and removing, down, it will stay at 32 because it's the biggest thing you'd added. You can also, with the generic lists that are part of C#, you can say, you know what, I want you to initialize to 500, and I probably am not going to be using more than 500 items. And so then it, you know, acts like it's got 2 items or 3 items or whatever in there. But as long as it doesn't pass 500, no problems. As soon as it passes 500, it doubles, and you've got 1,000. As you can imagine, that doubling comes with an expense because arrays are, to my knowledge, pretty much always on the heap, and so it's going to have to be garbage collected. Even if it's an array of value types like bools or ints or something, it's going to be, the array itself is not as raw as what you see in C++, for instance, to my knowledge. So at any rate, with the Swizzle list, the idea is pretty much the same. We come in and we say, I want an array that's never going to get larger than 500, whatever your number is. And under the hood, I'm creating 2 arrays. So instead of C# and the .NET framework in general being the thing that wrappers your list and says, hi, you've got 0 items in this list. Hi, you've got 2 items in this list, but really it's 16 under the hood. I'm doing that. So the Swizzle list is kind of recreating the concept of a list, and it's really using the exact same under the hood mindset. However, when we talk about array operations in an actual Unity list, there are a couple of problems. So, for instance, if we've got, I'm going to pretend like we've got 3 items in the list. Now, really, this list is 16 items, and 13 of them are blank. But supposing that we erase item number 2, with this list, it's supposed to take the item that is at number 3 and move it down to number 2. And so that would be a list.remove, and you would say index 1, which deletes index the item at number 2 since it's 0 indexed, and that shifts down. So in order to delete an item, we've now had a couple of operations. We've actually set an array entry to be null, the pointer to be null, whatever. And then we have gone in, we've done a access to an array entry to find out what the pointer is here. We've then done another access, or a set to take that value that we pulled here and put it down here. And then we've done another set to put this back to null. So we've done 2 sets and an access just to delete 1. Now, assume that your array is really tall and you delete this item here. As you can expect, it's just compounding the problem because it has to set this to null. Okay, grab this, put this here, 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 grab this here, put this one null. We're done. And of course, that then leads to this as the supposed result, but that is really inefficient. It's really flexible though, and it makes it so it's really nice because we can say, hey, what's at slot 12? And we can just go and get 12. We say, that's it. Here's item 12. So, oh, thank you. You can say, how long is it? It's currently 14 long, and you can iterate over it very efficiently because when you're iterating over it, it's just an array. And so it has its pros and cons. And if you want to insert something, it's the same problem as delete. You say, I want to insert this at slot 4, and it says, okay, cool. Now we need to bump everything above that up, put this in here, and then, oh, by the way, if this went over the current underlying size of the array, we're going to increase that. None of these are none of these are acceptable for the sort of performance profile that we need in AI War 2 for things that are rapidly changing. So enter the Swizzle list, and with the Swizzle list, for one thing, I don't want array sizes changing. There's no good reason for that. If you think there might be 1,000 items in there at some point, or you know there might be 5,000 items, RAM is cheap, especially when we're talking about pointers. We're talking about, I'm not sure how big these pointers are exactly. It's probably going to vary based on the bit level of the system, but let's say they're 16 byte pointers. Let's be real negative about that. I mean, that's ridiculously large, I think. But at any rate, suppose they were 16 byte pointers, and you define that there are 5,000 items, and you're never going to get near that. You hope you're not going to get more than like 3,000. But if you did somehow hit 5,000, then you just say, you know what? We're not drawing more shots than that. That's it. We're not drawing any more shots. You might make the number 10,000. It doesn't matter. But at any rate, you've now used, if the number was 10,000, you've now used 10,000 times 16 bits, which is nothing. I mean, in the scheme of memory that the program is using, that's nothing. And we don't have a whole lot of Swizzle lists, so that's a small price to pay for the efficiency we get of never having to, in the middle of things, go, you know what, let's make this list bigger. Let's do a whole array copy over, and then let's add a thing at the end. Now, so we've defined that we've got a Swizzle list that is X size, and we'll call this 1,000, whatever. The number doesn't really matter. It's defined 2 arrays in there. Now we've got what I call an active and an inactive list. And the premise of this is that with the Swizzle list, we want to do some stuff. We want to read from the active list, do some stuff with it, and as we're doing stuff with it, reaffirm what stays in the inactive list. Wait, what? Okay, right. So that's why this is that's why there's a video. So basically, since we have a game loop, this is for gaming, obviously. Since we have a game loop, that means that every time it loops through the overall sim process, in this case, the visual sim, we're having to traverse all the objects and do something to them. So in the case of, for instance, shots, we're saying, okay, you're a shot. You probably are headed somewhere. Move. Okay, you've moved. Are you done moving? Have you ceased to exist? Okay, if so, goodbye. We're done. Now, these shots are pooled, which means that when we're done with a shot, it gets put back in the pool, and that's a whole other data structure that we don't care about for purposes of this video. But there again, we are mitigating the negatives of the baseline list type by using a custom data structure. So with a Swizzle list, what we care about is the shots that are actually doing something. So at some point, well, let's say frame 1, we go, all right, these are my shots. And so these shots get put in the list, and we're like, all right, cool, those are the shots. On the next frame, we say, I think it's called actually Swizzle. Did I say Swizzle or I say switch list? Yeah, switch active list. And so switch active list will say, all right, take whatever's over there and put it over here. And at that point, then whatever was on the other side moves over here. So we're not actually moving anything, but we've got list 1 and we've got list 2 underneath the hood. and it's saying, which one is active? All right. So when we say get the active list, it will actually pull from the active list rather than the inactive one. We're also saying for pretend, how long is this? How long is this list? Are there 3 items in it? Are there 10? Are there whatever? And of course, the underlying array is whatever we defined at the start, 500 or something. We're keeping track of an int here that says, how long is this thing? List 1 and list 2. List 1 and list 2, which one is in the quote unquote active slot switches every time we iterate over this Swizzle list. It doesn't have to switch every last time, but that's the premise of why we would be using it. So every time you call switch active lists, it says, all right, list number 1 is now the active one, and list number 2 is now stale. This is where things get a little bit counterintuitive. But hopefully with the preface that I've had here that has now taken 16 minutes, hopefully why this is done this way makes sense. So let's say that I put in this many items into the active list the first time. Then I want to iterate over them and I do some stuff with them. Everything's happy. Great. Okay. I now say switch lists. So at this point, keynote, excuse me, as I'm going through the active list, one of the things that I am doing is I say add to the inactive list. Now, there are a couple of ways of doing that, but basically I say I process item 1. Is item 1 still something I want in the list? Yes? Cool. It's now added to the inactive list. I call that. How about item 2? Yes? Cool. All right. I keep on going up through there. This is assuming that there are no quote-unquote deletions. Deletion is a loose term here. And so assuming that all went well, now I have 2 identical lists. Well, that was kind of pointless, but all right. I now say switch list. It now says, okay, this was the king, but now this is the king, in terms of the active list. So, all right, now next time we iterate, we're going to be iterating over this guy. We haven't moved any data around. We did do essentially pointer settings where we said, all right, for every time we iterated over this one, we have then done a corresponding set into here. And there is a certain cost to that, of course, but it's vastly less than the cost of taking out an entry in the middle of a traditional .NET list and then having everything collapse down once, let alone, God forbid, we do something like this, and then we've got collapse, 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 collapse. That compounds fast in a very bad way, as you might expect. Okay, so at this point, Swizzle List seems kind of pointless. We've got stuff where we're iterating over it, and that's it. And if we want to add something, then we'd say, let's say we've got a new shot that we've added. We'd say add that to the inactive list as well. And so as we were going over the active list, we said, hey, add this one to the end. Now, what do we mean by add? That might have put it, we might be, so if the first list is active at the moment, we might be at this particular point processing the list. And for some reason we said, hey, add a new item. And we're like, okay. And so we did, and it's here. Now this item says, all right, are you still here? Yeah. Okay, add you to the inactive list. So now we're adding up 1. Here, add up 1. Here, add up 1. But it doesn't matter because all we're doing is we're saying add, and the active and the inactive lists don't necessarily correspond. They're not aware. So by the time we're done processing through this inactive, as soon as we're done processing through the active list, we've got a new inactive list, which is longer. You can probably see where I'm heading with this by now. So now we switch to this one being the active list, and we go, okay. Now, the first thing that I want to note is that I am in no way going back and getting rid of pointers in the old list. There's no point in doing that. So we say this thing is this long, this one is this long. And of course, really, they might have data coming up to here. It doesn't matter. In this particular example, we've got data going up to here, but it, quote unquote, doesn't exist for purposes of our iteration logic. Okay. So when we go get active list, it's saying, all right, here's your array, and here's how long this array is. Now, one of the things that I want to emphasize is that this is built for speed, not for idiot-proofness. And so if somebody gets the active list and then iterates over how long that actual list is instead of what this tells them, they're going to have a bad time. So, because they're going to find a whole bunch of stale data beyond where it was supposed to be, and who knows what's in there. There are ways that I could make that less efficient but more idiot-proof, but I'm assuming there's not a lot of programmers that are going to be working on this, and I'm also assuming that I want all the performance I can get, and I can, take the roof off the space shuttle here if we're talking about like the Martian. Take all the safety equipment out, take the roof off the space shuttle, and launch into orbit with no, under a tarp. That's what we're doing because, we've got a lot of mass that we need to move, and we want to move it quickly and frequently. So, yeah, you can shoot yourself in the foot with this pretty quickly if you don't listen to the comments. Now, at this point, we have a list that is quote unquote empty. It's not really, but we're pretending it's empty. At this point, on this side, we're now processing this new active list, which happens to be list 2, and we're saying, all right, do stuff with this one. Should we keep it? Yes, put it here. Do stuff with this one. Should we keep it? No. Okay, nothing happens. So in other words, when we said, should we keep this one? Yes, we set an array entry in there, and we actually incremented the how long is this list entry up to here. And then when we said, should we add this one? No, we didn't increment the how long is this list entry. That entry from the old list is still there, but as long as you don't iterate over it, which you shouldn't. You should be listening to the length thing, which is, of course, a less than, not a less than equal. As long as you're going less than, the total count, you're not ever going to hit that entry. We now go to item 3. Do we keep that? We go, yes. All right, cool. It gets assigned here, and now we assign, we increment the list length again. So now, in effect, we have just made a deletion. We didn't actually delete anything. And we've done actually fewer operations in order to do our delete than if we kept items in the list. Normally, keeping items in an array doesn't even require an operation, but here it requires a linear set of very cheap operations to keep stuff in an array. It has an existing, also linearly cheap operation to add an item, and it is a no-op, basically, to delete an item. Doing an insertion would just mean doing an add at a different, at a different point. So if I wanted to insert something here for some reason, which is really not what Swizzle List is about, but you can do it, then before I get to the point of adding the item after this one to the inactive list, I add a new thing, and voila, I have inserted things. But unlike the insertion in the direct list, the built-in .NET one, I didn't have to do any shifting of stuff up. Things do shift up, but they're shifting up at a linear rate based on how I am operating on the active list. Then I hit switch list later, and now list one is the active list again, and we're saying, all right, this thing now has 3 items in it. Loop over these. And there's all this other data that's hanging out here now. And we're like, ooh, wow, look at all that data. And obviously that stuff's not going to garbage collect, but we're talking about data that's being pooled somewhere else anyway. So not only do we not want it to garbage collect in the first place, it's not garbage. It's back in the pool. And the fact that we've got some latent references to it in our Swizzle list is really irrelevant. And what we've accomplished with all of this is that we've taken something that could be, so specifically we're talking about shots in AI War, and ships are shooting all the time. During a battle, there's new shots coming out all over the place. There's old ones getting deleted, because they hit something, and so on. And so they're popping in and out of the pools and moving around and doing things. And the last thing we need is for a bunch of extra array operations to be happening every time a new one gets added or one more frequently gets deleted. Because if we add a shot, we just slap that on the end of the list. Doesn't matter. But we delete one, well, we have to delete it from wherever it is in the list. And we can't really control that. My traditional way of handling that to reduce the number of operations is to iterate over the list backwards if I know that I'm going to be deleting stuff, because that way I hit here and I go, oh, deleting this. All right, these shuffle down. Yep, hitting here, these shuffle down. Hit deleting here, these shuffle down, etc. Versus if I go here and I go, whoop, delete, all that shuffles down. Hit here, delete, all that shuffles down. You might immediately go, wait, there's not much difference. But if I've got 10 deletions, I'm shifting an extra something like 9 extra items down that I don't have to. So that's what the Swizzle List is about. It's in Arkin Universal. I think I published the code for this out as well. It's possible that I have an error in this somewhere and that needs to be fixed. And so hence my explaining the premise behind it should help. However, more likely there's an error in how it's being used, because if you iterate over the entire length of the array that's being brought back, then bad things happen. This is implemented as a generic list, and so you can put bools in there, you can put Arkin visual ships in there, you can put whatever sort of class or struct in there you want to, doesn't matter. You can give it a name, and the reason why it has a name is so when it complains at you about something, then it can say, give it an actual name, like, list John is unhappy. Yeah, so you define it, you go to fixed capacity, it sets the max list length. That's cheaper to access than going list1.length or list2.length, which would be the same as max list length anyway. You'll notice these things are set as being read-only, which means they can only be assigned during the constructor. So somebody goes in and tries to change max list length later, it's going to error. So you define a Swizzle list with a certain size, and it is that size. End of story. From then on, when you do the get active list, that's where you really need to listen to this out parameter and iterate over that only to that length. So less than the active list length instead of less than length of the array that you get back. And there's a little handy clear inactive list there, which the quote unquote clear just says the list length is now 0. That's it. They've got add to an active list, and it's got a few things in here that will do things like say, was I successful? And so that's for cases where if you want to have it check, is there room in this? Is there, you didn't check the max list length before you called this for some reason. You're like, add it if you can. And it's like, sure. Or nope, didn't do it. Then this is the one you want to call. We've got add to an active list, no checks, which just takes off some more safety features and it's just like, here we go, we're putting it in. And if it's out of range, going to give you an index out of range exception, then that's what's going to happen. You'll notice that for when we're looping over stuff that is, assuming we haven't done any additions prior to or during the process of us iterating over the active list, then there's no reason to assume it's impossible for the addition to the inactive list to fail. So basically, there's the same number of total slots in both. So if I'm iterating over 30 things in the active list and then adding them one by one to the inactive list as I go, assuming I didn't have any other additions there in the middle, it is impossible for me to have an incorrect, get an index out of range exception. Items, as part of the principle of the Swizzle list, items are never added to the active list. The only thing we ever do with the active list is iterate over it. That's what the active list is for. So we've got one that's active, which is basically the data that we had before. These are the shots that we have starting as of last frame. Let's loop over these. And so we loop over them. And then we say, what are the shots we're going to have next frame? And we're telling that as we go. We say, well, this one died, so not him. This one's still alive, so him. And you're calling add to inactive list as you go. Now, when you call switch active lists, you're pretty much always going to want to say, clear the new inactive one. So basically that's saying, okay, the stuff that was inactive last frame that was that we were adding to, saying this is what we're going to be working with on frame 2. We're on frame 1 right now. We're going to be working with this stuff on frame 2. Therefore, frame 2's list is the inactive list. We're adding to that. Frame 1's list is the active list, which we're iterating over. Oh my God, this is complicated. Then we say, next time, once we hit frame 2, switch active list, the stuff that was inactive now becomes active, and what was active is now inactive and is meaningless. There's no meaning to that data, so we may as well clear it. I put this as a parameter rather than just having it implicitly happen, so that on the weird off chance that you don't want to have it clear, you can say don't clear. But even more to the point, I put it so that it's more obvious that a clear is happening. So you're saying, oh, I am clearing this. That's right. This is happening as part of that. Then you can actually skip going clear. However, there is a case in which you would want to do clear. Let's say we go to the galaxy map instead of being in a particular planet. There aren't any shots on the galaxy map. So at this point we say clear, and we clear the active and the inactive, which is basically just saying get rid of both lists. Set the fake length of both lists to be 0. And so it didn't actually adjust anything in the list, per the earlier demonstration in Photoshop. But instead, we're saying that it's empty. So one place you might run into a problem is if you are iterating over some stuff in the active list, and for some reason you forget to add it to the inactive list, or for some reason you are adding something to the inactive list in that interval of time between which you've iterated over the active list and then when you switch to actually that would still work. There are some edge cases. Let's boil it down to that. And I'm imagining that you can think of those. When you're looking at the actual in-game usage of Swizzle Lists, you can kind of think through it of, is this an edge case? Almost always no, but there might be one somewhere if you're running into a particular problem with it at the moment. Yeah, that's why there's not an add to active list, because that is completely against the whole point of a Swizzle list. And that's why there's not a get inactive list, because again, that is also against the ethos of it. So we're getting the active list, iterating over it. That's all ever. We're never inserting, adding, deleting anything on the active list. And on the inactive list, all we're doing is adding, period, end of story. No deletions, nothing, no inserts. But based on the order in which we add stuff and whether we choose to add stuff or not, that has implicit insert and delete capabilities, if that makes sense. So we wind up with effectively having iterate, insert, delete, and add capabilities, but only under certain circumstances. And those circumstances happen to line up perfectly with what we want to do with rapidly shifting lists of stuff that comes and goes that is pooled in another data structure. So hence Swizzle List. Thanks for watching.